My name's Greg Blomquist. I work at Red Hat. I'm a senior engineering manager, work in the automotive engineering organization, manage people in kernel QE and community, building demos for things, trying to improve the ISO standard that we use. I'm going to talk about none of that today. I'm going to talk about how to use AI to keep squirrels away from bird feeders. Before I jump into that, a little bit about me. I was born and raised in Portland, Oregon. Keep Portland weird. Met my wife in the 90s. We got married, had some kids, moved to North Carolina in 2003, and then in 2006, I started at Red Hat, so I've been there dangerously close to 20 years. And like I said, senior manager. I became a manager in 2014. Have worked on many different teams as a manager, and currently I'm in automotive engineering. My manager is here today. Okay, so what's the problem statement? Every spring, my wife would put out a bird feeder and fill it full of bird seeds. This image is AI generated, but the bird feeder we would use was 2 or 3 times the size of this thing. And for the first couple weeks, it would just be birds. And we're lucky enough to, off the back of our house is trees. There's a story there, but soon those trees won't be there. They're going to bulldoze it and put a road. But for now, we have trees behind our house. And that means there's birds, and the birds would fly back and forth from the trees to the bird feeder. And it was wonderful. Bird song, singing, all this great stuff. After 2 weeks, it was onslaught of squirrels. They would show up, and it would be like 1 or 2 at first, and then they'd tell all their friends, and all the squirrel friends would come, and they could deplete one of those bird feeders in like a day, probably maybe in hours. And if you've never seen a squirrel do this, they show up, they get to the bird feeder, and they just start stuffing their face. And they don't stop until their cheeks are like out to here. And then they scurry off, because they literally can't fit anymore. It's not because they're full. It's because they will explode. So they just keep doing this. And my wife got really frustrated. And I would joke around like, oh, you know what I could build like a thing that sees if there's a squirrel there. And then, I don't know, do something about it. And then I didn't do it. I didn't build anything for a long time. And then my wife got frustrated and just stopped. She just stopped putting a bird feeder out. And then bird flu happened. And then they were saying, you shouldn't put out bird feeders because they'll get sick. And when the stakes were lowest, I said, maybe now I'll go build something. So I went off and I tried to build this thing. The idea is to scare squirrels away from the bird feeder. And the approach is do some kind of image recognition to identify squirrels and deploy a terrifying deterrent. So introducing Squirrel Away. I have an actual project out there on GitHub that has code in it. It may not be the latest code I have on my laptop. I am very sorry. I am a bad software engineer. It's very important to know this is just a toy. Years ago, Mark Rober taught us squirrels are afraid of nothing. If you don't know who Mark Rober is, after this talk, go look him up on YouTube, Mark Rober, Squirrel Olympics, and you will see squirrels will not be deterred from food they can get a hold of. And I'm pretty sure squirrels will outlive cockroaches in the nuclear winter. I'm not an expert on any of this stuff. any of that stuff that's up there right now. I'm not an expert in any of it. But this gave me this was a toy, something I could play with and dive into some of these technologies. So like the AI ML stuff, I got to play with Bootsy and Quadlets. I was like in the room when people were talking about Bootsy originally, and I didn't play with it. Alex Larson he still is, in automotive, and he created Quadlets, and I didn't play with it. Raspberry Pis have been around forever. That's a lie, but they've been around for a while. And I had one on my desk, just sat there collecting dust. And there were other things like, these tensor processing units have been around. Containers even, I'd played with a little bit with containers. But I'm gonna focus this talk on the AI side. I played with all this other stuff, got frustrated by different pieces of it, had some successes. But what I'm gonna talk about today is the AI side. So what did I already know about AI? Not a lot. I had taken some courses on Coursera after ChatGPT kind of became a thing and people were getting all excited about stuff. So I learned, I took all those classes that I didn't pay attention to in college, or learned some things that I ignored in college, like linear algebra. There was some gradient descent and some more calculus and stuff like that. It was really fun. I had a really good time going through these courses, but I did it and then I walked away. So I didn't really have a strong AI background. I just knew some things. So I said I needed to know more. Let AI teach me AI. So this is how it started. I went to ChatGPT and I said, I want to build this system that does a thing. This is the prompt. I edited a couple things out of here, but this is the first prompt I gave it. And I just said, help me. Here's what I want to do. So how does a computer recognize a squirrel? There's something called a convolutional neural network. Some of those words might make sense to some of you. Who's heard neural network before? That's the power of AI. Who's heard of a convolutional neural network before? Look, about half. So to the rest of you, you might be looking at this going, what? What is this? So let's talk about AI. This is how a convolutional neural network basically works. This is a simplification of it. But take an image and kind of the convolution part is just scan across the image and do some kind of translation of it or inspection of it and come out with features of that image that the model thinks is interesting. What are those features? Like maybe edges of things, maybe it's color differences. Really, we probably don't really know what it's identifying as features. It's not necessarily the same way that we're going to identify features of pictures, but it's definitely going to collect things that look like features to it and put it into this map. And in the end, it's just a bunch of numbers. It's just a crap ton of numbers about what it believes is interesting about this picture. So do I have to build a model, a convolutional neural network model from scratch? No. So one of the things I learned in Coursera, that I had this word in my mind of transfer learning. So transfer learning is, let's talk about the where I started. ChatGPT took me down this path of, if you want a low power, small-ish model that does pretty well, start with this thing, MobileNet v2. There's a v3 out there. I didn't switch to v3 because I didn't have time. Like this talk was coming up and I needed to finish. So MobileNet v2 will say things like, here's a picture, and it'll say, oh, that's a squirrel. And it'll say, here's another picture. It'll say, that's a car. But I wanted something special. I didn't care about the other stuff. I didn't care if you saw a car, a dog, or a cat. I just wanted to know, is it a squirrel? So I added a layer. This is the transfer learning part. I added an additional layer to the model. So it could still say, yeah, that's a squirrel. If I give it anything else, that's not a squirrel. And I did that with code. This is effectively the code that transfers, that takes that initial model and turns it into the thing that I want. So I'm gonna walk through this. So this first little bit, start with the mobile net v2 model. It's pre-trained. It knows how to, like I showed the pictures before, it knows how to say things about pictures that it sees. And then I freeze that model. So any training I do after this point will not impact that original model. It still does the thing. And then I say, now add some new pieces to this model. That first one, so you see the base model, the gap layer, the global average pooling. Gotta make sure I know the words. And then a dense layer, which is really like how to output the results. That second one is just like, how do I take the original results and kind of compact them down a little bit? There's some fancy math going on inside there. And then the last thing says, you have one option to tell me, is it a squirrel? That's your only option. And that sigmoid function says, the results you give me are either 0 or 1. There's another type of function you can use that says it's either 0 or it goes off to infinity. And this one says, you can only tell me 0 or 1. And then compile the model. The loss function is a binary cross entropy. Everybody knows binary 1 or 0. So it's another restriction on this. There's some bits in there that are really common, like the learning rate. That 0.001 is just, it's kind of a common starting ground for the learning rate. People messing with that number is something that like you get into like the real refinement of the model. I didn't care that much. Like, I just want to see if it's a squirrel or not. And then in the end, you run it, you train it. So you fit the data to the model. That epochs argument is just how many times do you want to run this data through? And so the training generator just picks up images from a directory. And there's like an example of a directory structure. It's very simple. There's a directory called squirrel and a directory called not squirrel. It's up to you to make sure that the files inside those directories are correct, or you're going to confuse the model. And for people that don't understand what a neural network is doing during training, it's going to send. We got balcony noise. It's going to send this data through the neural network and come out the other side and have some determination. And it's probably going to be bad. The first time through, it's going to say, I don't know, that might be a squirrel. But its confidence level will be low. And then it'll look at the label and correct itself, and then it'll do this thing called backpropagation, which will go back through the neural network and correct some of those dials and things. And we don't really get to see what those are, what they're correcting, what the weights are. But it does this 15 times, so it's like this kind of going back and forth. So it sends the data through, and it gets better every time because it's adjusting those weights. And it's doing that gradient descent concept of like trying to find the minimum. So it's taking little steps down this valley into finding a minimum. Do you want to see it? Live demo. Okay, so this train sh is just calling some Python code that does the training. It's going to take a little bit to load up Python. TensorFlow app is, or TensorFlow library is pretty big. So I found 140 images, and it's training. This is on this laptop. I'm not sending this stuff off to AWS, GPUs, or this guy has nothing. It's just a little tiny CPU, and it's doing this. So that the number off to the left, that's counting up to 5, it's just batching the images and then throwing them through. So it's collected those 140 images into 5 batches. That number off to the far right, that's the output of the loss function, and you see it's decreasing over time. We hope. You might see some little like bumps back up, but it's on average trying to get down to a low number. And so it got down to, what is that? 0.02, 0.03? Is that good? I mean, the internet says it is, so great. We did it. We trained a model right here in this room on a poor little Lenovo. It's not even a Mac, guys. Okay, so, but that's fine. That's great. But how does inferencing work? Well, so it's the same thing. The model is now compiled. It's all one thing. And it just does the forward part. So we talked about the forward and the backwards propagation to try to train the model to say how it works. And this one just does the forward part one time and comes out with an answer. And I'll do another demo of that a little bit later. What were my frustrations in building this thing? I used to have, there were many slides after this one because I had a lot of like hardware issues that were very frustrating. Things like, I tried to get the camera module on a Raspberry Pi to work, and it just wouldn't recognize it. I was like, what? It's your own camera. Why don't you see it? There were lots of little things. I'm not a hardware guy, so I was like trying to figure these things out, asking ChatGPT so many questions, and getting like 70% of the answers that I wanted. But I'll talk about this. So this little guy is plugged into my computer right now. This is just a little tensor processing unit, USB connected. What does that mean? It means it can offload some of that work of the forward propagation for inferencing and do some of those calculations a little faster. This thing was, wow, okay. So this thing was built for, originally built for Ubuntu. I tried to get it working on Fedora. Oh, well, I did get it working on Fedora. It was a lot of pain, learning about things like deep-level USB things that I never wanted to know. And then TensorFlow versus PyTorch. So this guy only works with TensorFlow, only works with models built from TensorFlow. When I first started, I started writing this stuff using PyTorch, and it was very nice. Little details like, if I'm gonna grab a list of images from a directory and use that for training, somewhere along the lines in the training, I may wanna know, when you tell me this image failed, like it thinks it's a squirrel and it's not a squirrel, because I have the label, the directory name, I might wanna know that name of that file to say, well, which one failed? Let me go look at that picture and see what it looks like. PyTorch, it's just there. It's easy to find in the data set. with TensorFlow, I had to write my own data set because the original one to load files from a directory didn't think that maybe you wanted to know what the file names were that you're testing. Okay, so those were the two frustrations I left in to the presentation. I had so many more. I also just got a 10-minute warning. Hey, so let's go find some squirrels. I did not bring any live squirrels with me. And also, because I cut back on a lot of the things, including like, this is not a Raspberry Pi, obviously. And I'm not running this on a Raspberry Pi here at this demo. Yeah, I'm just gonna run this on my laptop. So let's go here. So what I have is a little shell script. I don't know how loud to make this. I have a shell script wrapping the Python that does the forward propagation to determine if there's any squirrels in any pictures in this directory of images. And then if it finds any squirrels in any of the pictures, it plays, or it, sorry, does a, what did I call it? A terrifying deterrent. Okay, everybody cross fingers. Yeah, no? Give me something. Live demos are the best. Get away. All right. I forgot how to use my own script. Well, that was really quiet. Are you terrified of the sound that came from my laptop? So that's literally, that's all it does. This was a big learning experience for me to go through all this stuff. I would run it again and make the sound louder, but it's moved all the images and I'd have to move them all back, and no one wants to see me CD my way out of a paper bag. What does that mean?
Have you tried that mechanical solution?
No.
Not for the detection, but for deterring them.
I will also redirect you. Oh, sorry. The question was, thank you. Have you tried a mechanical solution instead of noise? This is a two-part answer. One of them is, we could not get squirrels to come back to our house. We put out a bird feeder, and it had been so long, no birds came back, no squirrels came back. We could hear them in the trees, and they wouldn't come to our house anymore. They hate us. I mean, it's likewise, but whatever. The second part of that answer is, I encourage you to go watch Mark Rober's Squirrel Olympics.
Is that the one with the rotation?
Oh, no. He tries so many things. It is very funny.
The videos of the rotation, they're really funny.
Oh, yeah.
You can see how they
They will not be deterred. More questions? Oh, wait. I see a question up there. Great question. So the question was, where did I get the data to do the training? And what did I use as the negative, like these are not squirrels pictures? And this is the data set that I used is the same data set they used, or a fraction of the data set they used to train MobileNet v2, which is called ImageNet. You can just go to ImageNet, grab images, and they're already categorized. Now, I wanted them categorized specifically for what I wanted, which was squirrel or not a squirrel. So I had to like deconstruct their already categorized setup. But yeah, I just went and downloaded images of squirrels, cats, birds, dogs, many different types of birds. Because I was thinking like, is it ever going to be confused by that, like that one bird? Like a cardinal shows up and says, oh, that's a squirrel. I specifically chose like the type of cats that we have. Go ahead. You want to come back? I am very hard of hearing. They would have loved to play that role, and they have in the past. But we just couldn't get we couldn't get them to come to the deck for anything. Oh, the question was maybe it was your cats that wasn't keeping the birds and squirrels away. And yeah, they would definitely want to do that. And then okay, back to this. Okay, yeah. So the question is how. Some kind of. Oh, no. Okay, so the questions were, what was like the total size of the data set, and how did you split it up between training data, testing data, and validation data? This is a very common scheme for when you're training a model. You have these 3 sets of data. So I think I had like between 300 and 400 images total. Maybe it's less than that, maybe like 250, and then 140 in the training set, and then something like, I don't know, 60 and 30 in the test set and the validation set. And then the other question was, did you do any augmentation? Like, did you take a picture and rotate it, turn it upside down, skew it somehow to like confuse the model and say, sometimes squirrels are upside down. In fact, sometimes squirrels are upside down. But no, I didn't mess with the training data. I definitely could have, and what I saw in the results that I got was I was like the model was like 90% accurate, so it was pretty good. I maybe would have caught a cat once or twice. Did I see another? Yeah, over here.
Given all the frustrations you have, are you going to see it through to the end? I have another part. How many hotel rooms did you ruin during this demo?
I'm going to leave. No, the question was, I forgot the first question because I was so triggered by the second question.
Will you see it through to the end?
Oh, will I see this project through to the end? I'm seriously considering burning it all before I get on the plane home. No, this was a lot of fun to play with, and I'll probably will, like, I think I'm going to use this project as like the thing I use to play with new technology. Like other things I want to go play with. Like, oh, there's a new thing I haven't tried, or a very, very old thing that I haven't tried before. Let me go see if I can fit it into this setup. And then the other question was, how many hotel rooms did I ruin here? And the answer is 1. So I have an American surge protector that I plugged in a American adapter to the wall, plugged in my surge protector. Nothing was plugged into the surge protector. But people that know how electricity works will look at me and laugh still. I turned it on. Again, nothing was plugged into the surge protector, but I turned it on. And immediately the lights went out in the room. And then I went to the front desk and said, "Can I have a different room, please? I think I broke mine." And they said, "We have no more rooms." And I said, "Pretty please." And they said, "We can give you that room." And it's the room under the hot tub, the rooftop hot tub. And she told me, people that speak Czech as their first language may understand why she said this. I did not. She said, "There are maps on the ceiling." And I said, "That's fine. Because I don't care. Do the lights come on? Great." So I went into the room, and there's water stains on the ceiling. And someone told me, "Yeah, that's what that means." Like, it's maps. And I'm like, no. But no, apparently that is what it means. So there's maps on the ceiling. The power works, and the AC works. And I'm great. That's fantastic. Any other questions? Say that one more time.
Did you retrain the model based on your real images from your camera?
So the question was, did I retrain the model based on real images that I captured? And the answer is no. Because unfortunately, the person in front of you said exactly what happened, which is I'd never captured real images of squirrels because they didn't come to the house. Now, I thought of like running around the park, anyway, trying to find squirrels, and I never did. So the only images this has been trained on are from ImageNet. I did, like, at home, I set up a thing where a camera was looking at my iPad, and I had a picture of a squirrel there, and yeah, it said, "Oh yeah, that's a squirrel," but that's tantamount to saying I had the photo on my laptop. Like, there's basically no difference. But it's a good question. I did think about like what that process looks like. Like, when I detect a squirrel, throw that image into a folder that then, or into a directory that I can then keep and put back into the training data, and then train every month or so to kind of hopefully get better. And maybe some failures too, like throw some random number stuff in there to say, every once in a while grab a failed, like this is not a squirrel, and put that in the training data too.
Is there any rule of thumb when it comes to the amount of images you should use for training such a model?
So the question was there any, is there any like, oh, okay, yeah. That's a good question. So the question is there like a rule of thumb for how many images you should use? I'd have to go back and check my chat history with ChatGPT, because I'm sure I asked that question, and I think it said something like, "Hey, to start off, you could do like 100 images or something like that." And I was like, "Are you serious? I don't need 10,000?" You just do 100. So that's all I ever did, like the 140. That's all I ever did. Okay, I've just been told we're done. Thank you all for coming and the questions. This was really fun, great thing to work on, and see you all around.